today's session, LeaderTech Enclosure Shielding Solutions. My name is David Zimmett. I'm the president of Orion Technologies, LeaderTech's representative in Canada since 2016. I'd like to introduce you to today's presenter, Joshua Chastain, LeaderTech Application Engineer. He holds a Bachelor of Science in Mechanical Engineering from Florida State University and has been with LeaderTech for 8 years. Good afternoon, Joshua. How are you?
Good. How are you? Good afternoon.
How's the weather in Tampa Bay?
Oh, it's very good right now. Very warm.
Glad to hear. We're having a snowstorm. We're actually it just ended.
Oh, really?
Yeah, unfortunately. So prior to beginning, we would like to ask you folks a couple of questions. And at the end of Joshua's presentation, we will have a Q&A and would love to hear from you. You'll notice there's actually two tabs. There's a chat tab and a Q&A tab. Please use the Q&A tab during the Q&A session. Joshua will also show you a variety of samples, and you will also be able to download a couple of documents related to today's webinar topic. Finally, when the webinar is over, we would truly appreciate your feedback about this and future webinars we are planning. So let's get going with a couple of questions for you folks, just to get an understanding of where you're coming from and what your understanding is with regards to enclosure shielding solutions. So here's your first question, folks. We just want to get an idea of what industry you're in. Obviously, LeaderTech is involved in applications across the board in all these industries and much, much more. Okay, I guess we might have missed out on some categories because there's a high percentage of people who are involved in other applications. Okay, here's your next question, folks. Again, trying to get an understanding if you've ever used enclosure shielding solutions. So here you go. So what gasketing material have you used before in your applications? Conductive fabric over foam, conductive foam, electrically conductive elastomers, oriented wire elastomers, knitted mesh combo gaskets, beryllium copper / finger stock, other, not sure. And again, we're going to go through all these materials during the presentation. Okay, thanks very much for that, folks. Next question, we want to get an idea of what kind of frequency ranges you typically work in. So here you go. What frequency ranges are you trying to shield from? Kilohertz level, 100 to 1 gigahertz, 1 gigahertz to 5 gigahertz, 5 gigahertz or higher. Okay, pretty much a good split. A lot of people in the 100 megahertz and 1 gigahertz. And by the way, folks, there will be an on-demand video available, and we'll be able to share all the results of these polls with you. Okay. Here's another question for you, just again to get an understanding of your experience. So do you have any experience with EMI, RFI, enclosure gasketing? You're up for a challenge there, Joshua, because yes, indeed, there's a higher percentage of people that have experience with enclosure shielding than those who do not. This is a question that quite often comes up, and again, we want to get an understanding if you have this type of requirement. So here you go. Do you often require an EMI seal combined with an environmental seal?
Pretty split.
Okay. Yeah, pretty much half and half. And again, Joshua somewhat will cover, what standards they can meet for some form of environmental seal. Okay, great. That's it, folks. We appreciate your time. So what we're going to do now is we're going to start the presentation, followed by Q&A, downloading of documents related to today's topic. So let's start the presentation now.
Hello, everyone, and welcome to this webinar. My name is Joshua Chastain, and I am an applications engineer at LeaderTech. This webinar will explain the enclosure shielding products that LeaderTech manufactures and how they work. LeaderTech is located in Tampa, Florida, and we have been in operation since 1984. We like to think of ourselves as a full-service EMI solutions manufacturer. We specialize in circuit board shielding, enclosure shielding, cable shielding solutions, absorbers. We work with all aspects of industry: aerospace, military, defense, telecom, medical, and commercial industries. We have around 130 employees. All of our manufacturing is done at our facility in Tampa, Florida. LeaderTech is a subsidiary of HEICO Corporation, a global aerospace, defense, and electronics company focused on niche markets. Operating for 62 years with two defined segments: flight support and electronic technologies. Our enclosure shielding products are designed for specific applications. Finding the right one starts with determining the application. EMI, RFI gaskets are fundamentally used to create an electrical seal between two surfaces: doors to enclosures, joints between faces, grounding, etc. All of our gasketing options perform this function. Now, the most important question is, what is the application? You can use two classes to further separate our enclosure shielding products and get closer to finding the right one for your application. One, there is mechanical, high cycle applications where a door is frequently accessed, being open and shut, a gap that can vary in size with the opening and closing, and wiping applications, to name a few. And two, there is low cycle and or environmental seals. These doors or compartments are rarely or infrequently accessed, and these can also offer protection from fluids, dust, or moisture. This slide shows the two classes and the enclosure shielding products we offer for each. For high cycle applications, we offer FSG, which is an acronym for Fabric Shielding Gasket, and beryllium copper fingerstock. For low cycle applications that also offer an environmental seal, we offer knitted wire mesh combo gaskets, oriented wire, and conductive elastomer products. For low cycle and non-environmental needs, the FSG fabric shielding gasket, knitted wire mesh, and conductive foam products work. For the next few slides, I will focus on the two high cycle enclosure shielding products: fabric shielding gaskets and beryllium copper fingerstock. Beryllium copper fingerstock is made from beryllium copper sheet metal, formed to the desired shape and heat treated to maximize the strength of the material. Choose beryllium copper when significant dynamic range is desired, wiping or shear forces are part of the application, or if the gasket must withstand a high number of cycles. FSG is extruded polyurethane foam with conductive copper nickel fabric wrapped around it. FSG gaskets are a more economical option than beryllium copper and are simply applied with a pressure-sensitive adhesive where you need them. Beryllium copper alloy is composed of 0.5% to 3% beryllium and is non-magnetic. It is used a lot for high reliability contacts and springs. We offer a variety of shapes and offer some extreme low profile options like the one pictured here. You can see a profile view or side view of a shape in 4 different stages of compression. There's the initial stage with no contact, the minimum recommended compression, nominal compression, and then the maximum recommended compression. We have named some of the series of fingerstock according to their mounting method, and some have been named according to their design. There's slot mount, which clips into slots or slides onto mounted tracks. The folded series offers a large range of deflection and compression forces and are available with or without tape for alternate attachment methods. It's also available in a snag-free version where, under compression, the leading edge of the gasket slides into an extended and folded base, which prevents possible damage to the gasket. You can see that here. Compact PCI gaskets are designed for easy card insertion in rack mount applications. And the Twist series gaskets are designed for demanding compression applications. This series can compress to material thickness and is also available with or without pressure-sensitive adhesive. The list you see here is our standard plating options and their finish code for our part numbering system. The plating provides corrosion resistance for the fingerstock and, depending on your application, allows the beryllium copper fingerstock to mate with the other metal surfaces in your application. Our standard option is an unplated bright finish. You can see the letter code BD. We have many standard sizes and shapes available for our fabric shielding gaskets, and they are easily customized as well. We can make new sizes to the standard shapes and can also accommodate custom shapes to fit your application. The material can be die cut and laser cut, as you see here, and is great for custom I/O panels. We recommend them for frequency ranges from 20 MHz to 10 GHz, operating temperatures from -40 to 158 Fahrenheit, and have measured shielding effectiveness from 80 to 115 decibels. The material has passed a flammability rating of UL 94-V0, and it is available with or without conductive or non-conductive PSAs. Switching over to low cycle and non-environmental applications, I will focus on knitted wire mesh and conductive products for the next few slides. Our conductive foam material is composed of resilient nickel-copper polyurethane foam layered between two pieces of conductive polyester fabric. This material is manufactured in sheets, and we can further die cut and laser cut the material to meet the needs of your application. This makes it also great for I/O panels. The target application is frequency ranges from 10 MHz to 3 GHz, operating temperatures of -40 degrees Fahrenheit to 150 degrees Fahrenheit, and can also provide an average shielding effectiveness of 60 decibels. We recommend 30% compression of the material and is standard with or without conductive adhesive. Knitted wire mesh gaskets consist of many interlocking loops that act as small springs which provide for a resilient, all-metal conductive gasket with high attenuation characteristics. It can provide shielding effectiveness up to 130 decibels in the E field and up to 80 decibels in the H field. The standard wire materials are tin-plated copper-clad steel, Monel, and aluminum in cross-sections of rectangular, round, round with fin, and double round with fin. All cross-sections are available in both all-mesh or elastomer core configurations. If your application requires an environmental seal, these next slides will describe conductive elastomers, knitted wire mesh combo gaskets, and oriented wire. LeaderTech's conductive elastomers are made from 2 polymer bases and are mixed with 6 different metallic fillers. Both the silicone and fluorosilicone polymer bases offer shelf lives up to 20 years. Fluorosilicone differs from silicone because it contains trifluoropropyl groups, making it highly versatile for outdoor sealing applications or environments where exposure to sunlight, ozone, chlorination, or aromatic hydrocarbons is common. With the polymer bases, we use 6 conductive fillers to make 11 MIL-DTL 83528 certified materials, and some compounds outside of the military spec. MIL-DTL 83528 is a U.S. military detail specification for design requirements of conductive elastomers, such as the material, the performance of the material or part, and the limitations of the material or part. The scope of the specification says, this specification establishes the general requirements for electrically conductive elastomeric shielding gaskets. These gaskets are intended for use in electromagnetic interference, radio frequency interference, suppression applications. Having conductive elastomer materials approved for manufacture by the U.S. Department of Defense signifies that it has passed the inspections and tests of MIL-DTL-83528. This testing and inspection methods have their own requirements and standards as documented in their corroborating MIL or ASTM testing spec. There is a main specification that details the material compounds and their required characteristics, and 16 further specifications that detail their unique part numbering system, which you can see here, and part numbers, standard shapes, tolerances, sizes, all for extrusions, sheets, flange gaskets, O-rings, and waveguide gaskets. Conductive elastomers are composed of over 65% of the conductive metal filler. We combine the metal filler and polymer base in-house and use it to fit many applications. We mold sheets that can be die cut and laser cut and can extrude to multiple shapes. The extrusion can be bonded to make O-rings and frames. We also compression mold O-rings, frames, and waveguide gaskets. Mounting the conductive elastomer will depend on the shape and your application. As you see here, we recommend a specific deflection compression for every shape of the material, so it will be effective in the application. For grooves, a friction fit is recommended if possible, and at full compression, we recommend a maximum of 97% fill of the gasket in the groove. Rivets, bolts, spot bonding, and PSA are other ways to mount. Non-conductive adhesive is recommended for PSA and for spot bonding because conductive adhesives sacrifice adhesion strength with the addition of conductive particles. Knitted wire mesh combo gaskets are comprised of Monel or tin-plated copper-clad steel knitted wire mesh, which is then bonded to neoprene sponge, silicone sponge, or solid silicone elastomer strips. They are cost-effective for low cycling applications, provide high shielding effectiveness over a broad frequency range. The knitted wire construction provides long-lasting resiliency, and the combination with elastomer offers protection against moisture and or dust. Oriented wire gasketing is constructed of Monel or aluminum wire oriented perpendicular to the mating surfaces and embedded in solid or sponge silicone elastomer. The wires create an electrical connection between the mating surfaces as well as create an environmental seal. They are only conductive in one axis, along the wire. The wire is crimped for additional resiliency and to optimize the mechanical performance of the gasket. It has between 700 to 900 wires per square inch. The material is available in strip or sheet form and can easily be die cut or laser cut into complex shapes or fabricated into custom frame gaskets. To alleviate electromagnetic interference and also make electrical contact, two metals need to mate. If those mated metals are contacted with a corrosive electrolyte such as water, galvanic corrosion can occur. A galvanic compatibility chart is a good tool to help decide the plating, wire, metal, or filler that may work best for your application. The electrochemical voltage between that metal and gold can predict the compatibility of metals. This is called the anodic index of the metal. The chart shown here lists 38 groups of metal with an anodic index voltage. For harsh environments like outdoors or high humidity, it is recommended that the difference between the metals not be more than 0.1 volts maximum. For example, nickel is 0.3 volts and beryllium copper is 0.35 volts. Their difference is 0.05. These metals are very compatible. For normal conditions, we recommend a max difference of 0.25 volts. This would be something like a warehouse that is not temperature or humidity controlled. And for controlled environments, we recommend a difference of 0.5 volts max. The best prevention for galvanic corrosion protection between the enclosure shielding gasket and mating surface is to choose compatible metals, plating on one or both of the mating surfaces, and controlling the environment from things like humidity or soil. All of our enclosure shielding gaskets require compression. We recommend a compression range for each product line and shape. If the gasket is compressed below the recommended range, it may not provide the intended performance. In the case of conductive elastomers, the material is metal particles with a binder. Those metal particles can only contact one another with compression to create electrical contact. Over-compressing the material can also cause issues. The material can break and overcompressing conductive elastomers can create separation between the metal particles and reduce conductivity. Compression set and permanent set is also possible, and for some materials may occur within the recommended compression range. Depending on the size, temperature, percentage of compression, and the amount of time compressed, the material may not rebound fully to its original height. This is compression set. For some applications, such as low cycle or permanently closed gaps, the compression set may not affect the application. In conclusion, here are some key points to ponder when trying to determine the best enclosure shielding gasket for your application. What is the operating environment? Is it inside or outside? Is it a high cycle or is it a low cycle application? What materials will the gasket be mating to? How do you require the gasket to mount to your application? Are there space and weight limitations to your application? We appreciate you for taking the time to listen to this webinar. Please let us know if you have any questions.
Great. Thank you very much. That was a great presentation, Joshua. Thank you very much.
Good. Yeah, no
Okay,
problem.
folks, I actually thought it would be a good idea for us to show you, or actually Joshua to show you a couple of samples. So there's a kit available. This is called the Kit 99. Joshua's going to go through that.
So here's a Kit 99, which we can provide. It's a good kit that shows some of everything. It's really a good booklet to really just get a nice feel and touch of the different enclosure shielding products we offer. Here's some, first page with some fabric shielding gaskets. Here's beryllium copper. Put that on the camera. Conductive elastomers as well. A few different things you can feel around there, different materials. The knitted wire options we have, along with conductive foams, two different types of that. And it's just got basic information about each of those. And then we have other kits available as well. Or samples available.
Yeah, this one here is called the Kit 20. This one is also available. And it has a variety of samples, anything from some examples of extrusions, die cuts, elastomer cores, etc. That's called the Kit 20. So your local Orion Technologies representative will actually reach out to you and ask you if you would like one of these kits. Also take in consideration that all the Orion offices have larger sample kits that have a variety of beryllium copper samples. So if you need some finger stock very quickly to do some prototyping, contact us again. We might have exactly what you're looking for or something close to what you're looking for. And same thing with regards to fabric shielding gaskets. We have, large strips available in all of our offices. And just, again, go ahead and ask your local Orion representative for a sample. So that's it, folks. Let's proceed with the Q&A. Does anybody have any questions for us? And please try to use the Q&A tab. Yes, somebody's asking if we'll be able to send the presentation slide deck. Yes, we will be able to provide you with that. We'll actually also publish the actual presentation on Orion Technologies website.
Okay, so Ray asks, what's the difference between die cut and laser cut? Die is a blade, so it's basically a blade put into a piece of wood or plastic or even metal that's pushed in to cut the material. Whereas the laser is an actual laser on a pulleys or machinery that will cut out the shape itself.
Okay. Next question. Does LeaderTech have galvanic data for FSG fabric shielding gaskets?
So FSG is not really meant for environments where there's catalysts like water or soil. So it's more meant for climate-controlled environments, where you wouldn't be concerned with galvanic compatibility.
Okay. Next question. Some gentleman is looking for a metallic gasket for D-sub connectors, beryllium copper, gold-plated, but he cannot find one for 104 position D-sub, which is shell size number 6. Does LeaderTech have one as a standard item, or is this a special custom part? Yeah.
I'll need to
104
look into
position is 104 positions, by the way, is not a standard number of positions. There's actually a link on LeaderTech's website for some of the standard products that are available. Typically, D-sub 9 position, 25 position, 37 positions. But take in consideration that over 90% of the solutions that LeaderTech builds are custom. So no issues being able to build a 104 position
exactly
metallic gasket, right? Okay, next question. Does your kit have an indication of whether the different parts are rated for total mass loss, TML, and collected volatile condensable materials, CVCM, for outgassing in a vacuum? Take into consideration that this is most likely linked to a space type application.
Right. As of right now, we have not tested for outgassing properties, but we are looking into that and hopefully have something soon.
Okay, thanks. Next question. Do you know the shielding effectiveness of these types of gaskets for which frequency ranges? I guess which frequency ranges make them, are they more effective for?
We have done some testing on some of the gaskets, which we can provide if you know the specific one you'd want information for. It's limited. It's not. It's a relatively expensive test to be done, so we can look into it. Some of our catalog pages do have that. I'd have to look and see the specific one you're referencing.
Yeah. So if you could provide us with more details, we'll look into if we actually have existing data available or not. Next question: can conductive elastomers be stretched?
We do not recommend. It is more meant. They're definitely meant for compression. Stretching, we do not recommend. It's not meant for that. The particles can actually be separated, and you could reduce the performance of the gasket.
Okay, thank you. Next question. What is the lifespan of the adhesive strip on fabric over foam solutions?
I'd have to look at. It's a 3M adhesive. Off the top of my head, I want to say 2 years, but I need to look exactly at I think it's 3M467 is the exact adhesive. I'd have to look at the 3M data sheet to tell you off the top of my head.
Right, and you actually offer two types of adhesive, a conductive and non-conductive. Would there be a lifespan? And would there be a difference in the lifespan of?
There could be, yes.
Josh, this is Todd Kerrigan. I think I can answer that one. For all the standard PSA, we suggest, we have a lifespan of 1 year. The PSA actually is 2 years, but when applied to ours, we say all the product that we offer is 1 year.
Okay.
I hope that answers the question.
All right, next question. Conductive elastomer O-ring approximately 20 inches inside diameter. What's the smallest feasible section diameter?
I want to say our smallest extrusion diameter is 40 thousandths of an inch. As far as O-ring molded, well, we wouldn't mold a 20-inch ID, so it would be a bonded extrusion. I want to say 40 is our smallest. 40 thousandths of an inch.
All right. Let's see. Any other questions, folks? Well, while you're thinking about it, let's permit you to download a couple of documents. So the first document is actually a shortened version of this catalog, which you can download off LeaderTech's website. It's an enclosure shielding solution, so it pretty much covers all the materials that Joshua covered today. This particular downloadable document covers really more so the selection guide, galvanic compatibility chart, etc.
While you're doing that, Ed asked what has the best shear resistance. The best shear resistance is going to be the beryllium copper material and gaskets. The fabric shielding gaskets it's called a ripstop fabric, which does offer some general resistance, but beryllium copper.
Okay. We have another question. What are the advantages of laser cutting technologies?
So it's a very fast process. We just program the machine. There's no NREs, so it's a quick turnaround and good on price as well.
Okay, thanks for that. Next question. Fabric over foam gaskets are interesting. However, there's a huge concern for debris or particle shedding. For a D-sub connector, can fabric over foam gasket be used? If so, how could you contain the cut edges?
We do have D sub fabric over foam gaskets, and there's if that is a concern for containing the cut edge and debris, I would definitely point you in the direction of a beryllium copper D sub gasket.
Okay. Next question. What types of materials can be laser cut? This is a follow-up to the last question.
We can laser cut most of our materials. Pre-tin plated steel, alloy 770, all of our conductive elastomers, the conductive foam, fabric shielding gaskets FSG, and oriented wire as well.
Okay. While we're waiting for more questions, we'll permit you to download a second document, and this is really a LeaderTech capabilities brochure. So it covers not only today's subject, which is enclosure shielding, but also will cover circuit board shields, cable ferrites, microwave absorbers. We have a last minute question here. Do you have gaskets similar to 1/Spira Shield Forms, Spira Company, which are twisted spring temper beryllium copper materials 2GOR? I guess we'll have to look at the spec. 2GOR Shield GS 2100, which has become obsolete for procurement. So,
I mean, I'm not familiar with that. I would have to look that up.
yeah. So, Victor, we'll get back to you. I guess we just need to look up the specifications of this part. Next question. The beryllium copper D-sub gaskets are waved or with finger stocks?
They have bent fingers. We have made waved beryllium copper gaskets. I'm not sure if they were exactly D-subs, but that's possible as well. But our standard D-sub gaskets are with fingers, bent fingers.
Gotcha. Thank you very much. All right, folks, this wraps it up. I'd like to thank Joshua for his precious time.
You're welcome.
Of course, LeaderTech, and of course, you folks, thank you very much. I remind you that you'll have a very short survey when I end this webinar. We would really appreciate your feedback. We would really like to basically provide you with better content. So please take your time. Thanks again for showing up, and have a great day.